Okay, folks, let's get after it. We got a mini lesson here called 5 Functions, 5 Rules, and 5 Theorems. This is a little bit of review for you for the AP Calculus AB exam. I will tell you that the inspiration for this was a YouTube video I saw from an MIT professor. He actually did 6 functions, 6 rules, and 6 theorems, but 5 is more appropriate for our world here in AP Calculus AB. Okay, so let's go ahead and get after it. We've got a table here of functions, and going this direction we're going to be looking at derivatives. Going this direction we'll be looking at antiderivatives, and this is basically a review of every type of derivative and antiderivative we looked at this year. So the first one we learned, power rule for derivatives. Pretty straightforward, n times x raised to the n minus 1 power. The power rule for antiderivatives is going to look like this. Don't forget the constant of integration. Be careful though, this one only works when n does not equal -1, when that exponent does not equal -1. All right, now let's look at some trig stuff. The derivative of sine x is cosine of x, antiderivative sine x, negative cosine x, plus the constant of integration. Remember back when we first discovered the derivatives of sine and cosine, we kind of looked at them as a wheel of derivatives. Looked like that, and we said if we're going this direction, then we're talking derivatives. If we go the opposite direction, counterclockwise, then we're talking about antiderivatives. So keep this guy in mind up here as kind of a little memory device for you to help you remember trig derivatives and antiderivatives. Let's finish off here with cosine. Derivative of cosine, negative sine x. And the antiderivative of cosine, we're back to sine of x plus a constant. Okay, now let's look at e raised to the cx power, where c is a constant. If you recall, the derivative with respect to x of e to the u is e to the u times u prime. Well, the version of that where u is just c times x, that'll just be c times e to the cx power. The antiderivative of that is going to be of e to the cx is 1 over c times e to the cx power plus a constant of integration. I better not call it the same c because they are different c's in this case, so I'm going to tag it as c sub 1. Last but not least here, let's look at the natural log of x. The derivative of ln of x is 1 over x. And then the antiderivative of ln of x, this one's a little tricky. It's x times ln of x minus x plus some constant. If you're wondering where on earth does this come from and how did I miss the memo on this one? No, don't worry about this. Dog is not happy. This requires, he's not happy because I didn't tell you about this. This requires something called integration by parts, but don't be alarmed. It's not on the AB exam. This one is a BC only topic. Okay, let's see if we can't get them settled down and then move on. Okay, now that we got the dog settled down and we're done with 5 functions, let's go ahead and move on down here and look at 5 rules. So these are some basic rules for derivatives and antiderivatives. We'll start with the, this is kind of a combo here of, I list it here as the sum rule for derivatives. But it's also a combo of sum and constant multiplier. So this one would look like this. It's just the sum of those two derivatives times that constant multiplier in front of each. Same idea here with antiderivatives. If we call big F of x the antiderivative of little f, and we call big G of x the antiderivative of little g of x. Oh, look what I did not give myself room for here, people. Plus the constant of integration, that's better. Okay, now let's go ahead and I do want to show you one other form of this one, just because I think it's easy for students to forget. What if we had this? What if we said a times little f prime of x plus b times little g prime of x, and we integrate that with respect to x? Well, remember, the antiderivative of a rate, because a rate is a derivative, is back to the original function. So this would just be a times f of x plus b times g of x plus c. Okay. Now let's talk about a product rule. The product rule for derivatives says if we have the product f times g and we want to take the derivative of that product, it's going to be first times derivative of the second plus second times the derivative of the first. And we've been working with that since very early in the year. Remember this, there is no product rule for antiderivatives. So what you should think about is expand if possible. All right, how about quotients? Well, we do have a quotient rule for derivatives. It looks like this: low d high minus high d low, all divided by low squared. There is no quotient rule for antiderivatives, unless you consider this one. The antiderivative of 1 over u du is equal to the natural log of the absolute value of u plus some constant. That's kind of a quotient rule. It works for special cases. Also, there are some quotients that who have antiderivatives that involve inverse trig. Don't forget about those. Okay, how about a composite function? Oh, guess what? It's our friend, the chain rule. Remember, folks, if you haven't used the chain rule in the first 15 minutes of the exam, you might as well get up and walk out. It's going to be on there. We have the derivative of the outside function, leave the inside all alone, and then we multiply by the derivative of the inside, g prime of x. There is not really an equivalent for antiderivatives unless you consider u substitution. U substitution is how we turn composite functions into just a straight function and anti-differentiate it. Okay, let's move on now and talk about inverses here. So we do have an inverse rule, and it is the following. If g is the inverse of f, so if the function g is the inverse of f, the derivative of g is actually 1 over f prime of g of x. So there's a reciprocal relationship there between the derivative of the derivatives of inverse functions. And recall this: if f of a equals b, then g of b equals a. That's that whole idea that a comma b on the graph of f is b comma a on the graph of its inverse. And there is no equivalent here for antiderivatives, so don't worry about that. All right, folks, let's shut this down and then pick it up on page 2.